Recording in progress.
So, hi guys, good morning all of you. Guys, I'm audible. Okay, right here. So come out here. Yesterday we started indexes and the B-tree indexes in this the first type of index here, simple index. And when we called simple index means when we created index object on a single column, okay, then it is called as okay, simple index we called. Okay, right. So now your syntax is create index name on table name of column name. Okay, and now I was given okay one column name salary. Okay, on EMP table of salary here. Okay. Now, so this is our index creation, guys, here on salary column, and your index is successfully created here. Okay, right. But this index is created or not, if you want to see. So there is one data dictionary. So user underscore ind underscore columns. Okay, right, and this is what. But observe guys here. Okay, right. But when you are creating, okay, the simple index, okay, on based on particular column, then first of all, what we said here, that it is a B tree index is created. And B tree indexes are default indexes we called here. So now whatever we created the simple B tree index, okay, on this column, then this column data, how it was going to be arranging here, let me check. Okay, now, so after creating this index here, so what we said, it was created, B tree indexes are created now. So how this B tree index will be there means here option. So now let me find out here. The first of all, after created this index here, observe. Now I'm going to requesting, my request is what now? Suppose select a start from EMP. So where salary is equals to 3,000 rupees. So this is our request now. So when we send this request to server, on which condition basis, okay, on which condition basis, okay, are you retrieving your data? And already on that column, you have an index object. Already on that column, you have an index object. Okay, now, so that's why. So whenever we are asking, okay, sal is equals to 3,000. So based on this condition, okay, so data arrangement will start it. That means your B tree started with the root. Okay, how much root means your condition value is root. So that is 3,000 rupees is my root. And the root value, okay, right pointer RP is nothing but right pointer and left pointer here. Okay, so left pointer and right pointer. Your LP RP means what now? Left pointer and right pointer. Okay, so 3,000 is a root value. So root value how to take means based on my condition, I want to take my root value. The root value left pointer, root value right pointer here. Okay, right. The left pointer, okay, which kind of values will be saved, and left side means it's less than values. So the value which is less than to 3,000, so 3,000 less than values are saved into left pointer. Okay, and 3,000 above greater value or equals to saved into, okay, right pointer. Okay, now, right. Okay, right. So now guys, here the 3,000 is my root value, and 3,000 less than values are, okay, storing at left pointer side, and 3,000 greater than or equals to values are saved into right pointer. Okay, now, right. So this is what it was happened, and this is we called as what now? Root level. Okay, now, right. So now next one here, this is root level. And now let me see how the data can be arranged here. Observe now. So come to your database table. And this is our table, guys. Okay, now fine. So now the salary column information, whatever it was there. So this data, okay, will arrange it into binary B tree or binary format. It will be arranged. Okay, binary tree structure format. It will be arranged here. Okay, now so let me come to one by one compare here. Okay, now right. So when you compare into 3,000, okay, let me come out in this salary column. in the salary column, there are 14 values are there here. Okay, there are 14 values are there here. But out of 14 values, okay, which is biggest value in the salary column, guys, here? What is your biggest value in this? Yes, 5,000 is the biggest value. So when you comparing to this 5,000, when you comparing to 5,000, okay, so compare with the 3,000. Now tell me, 5,000 is more than 3,000 or less than 3,000? Come on, guys. 5,000 is a more than or less than? Yes, it is a more than. More than means which side it will be saved here? Right side or left side? Yeah, right side it will be saved here. So now right it will take now. Right it will take, and again same as, okay, left pointer, again same as left pointer, which is less than values, okay, less than to 5,000 and greater than or equals to, which is right pointer. So I kept this. In the next one, come to next one. What is the next biggest value in this, guys, here? So 3,000 is the biggest value. But here 3,000 salary employee rows. How many rows are there? 3,000 rows. How many rows are there here? Two rows are there. Okay, right. So compare with the 3,000 in the root value. So 3,000 is equals to 3,000. That means 3,000 is equals to 3,000 means which side will come to you? Right side. Okay, so right side, this is which level? This is called as a parent level. Okay, now right, when you comparing to root level, it was comes to right side. Right side already parent is there. So compare with the parent here. Compare with parent. Then 3,000 is a less than 5,000 or is greater than or equals to 5,000. Yes, it is a less than to 5,000. So less than to 5,000 means which side it will be saved? Which side it will be saved? In the left side. Okay. So it will be saved here, left side. So left side, 3,000. 3,000. But 3,000, here we said, how many rows we have it here? 3,000. Two rows are there. So here each row identification is called as a star, comma, star. So here two stars I were taken. So here what is star is nothing. Star is nothing but row ID. Okay, na? Yes, star is nothing but what now? Row ID. And already we discussed row IDs. So in a table, every row ID is a permanent row ID here. Okay, so based on the star is representing row ID. So based on that row ID, directly jump to that row and fetching the data. Okay, that means these rows are the first year. These rows are not searching by server, directly based on your row ID, directly jump to your table, that particular row and fetching the data. So that means here row ID, how it was representing means it's like a page number in your textbook. Did you remember na? Page number in your textbook. So that means here starting I was given now. Yes, starting I was given now. So whenever you know the page number, whenever I know the page number, my required topic in which page number if I know, based on this page number, directly jump to your page number 45 in your textbook. Okay now, so how we can directly jump when I know the page number, my required topic, where it is located, the page number when I know, then it is based on that, how I can jump to here, same as guys. Same as a star means what I said, row ID or page number. Okay, so based on this star comma star, Your first star means first row ID. So based on this row ID, directly jump to your table and that particular row ID got it. And after that, what next? Second row ID. Second row is what now? Here 3000. So second row ID directly jump. So that means directly based on the row ID number, directly we are fetching, but we are not searching the remaining rows in a table. Okay, now so this is the advantage of indexes. Okay, let me see. Okay, fine. The 3000 I arrange in the left side, and the star is nothing but row ID or page number. Okay, now and later in the same pattern, what is the next highest salary after this 3000? Come on, guys. What is the next row ID after this? Yeah, next one is called as a 2975. The 2975, when come back to here, compared to 3000, which was comes the left side or right side, guys? Yeah, left side, because less than to 3000. So left side, I'm just keeping here. I'm keeping left side now. So what I want to say, same as, okay, LP. If I want to take LP here, which is less than to the 2975, and suppose if greater than or equals to, then it will be right pointer. Okay, now so this is your parent level. Okay, fine. So now this will be saved like this. In the next one is, what is the next highest salary, guys, here? 2850. So 2850 is having only one time. Okay, let you come. So compared to root, it's a less than value. Less than value means where it will go left side. Left side already 2975. So when you comparing to 2975, again which side it will be saved, guys? Left side. So now you can come out and see, guys, here. Okay. Okay, now you can see the 2850 is taking only one star here because it was having 2850, and I will one star. So I keep it like this in the left side. The same as after 2850, what is the next highest salary, guys, here? 2450. So 2450 is also having only one time here. So let me come out and compare this 3000 left side, 2975 left side. So here I'm taking here, okay, 2450 is comes on the left, and here I will take only one star because one row ID it was there. So like this, next one you can see 2450 after, what is the next highest salary in this table? 1600. 1600 after, what is the next highest salary? 1500. So 1500 after, what is the next highest salary? 1300. 1300 after next highest salary 1250. But 1250, how many 1250s are there here? How many 1250s are there here? 2. So remaining all are which is less than. Okay. So then what I want to do, comma, and the next one is what was the next highest salary? 1600. So 1600 is also comes left side, and it is also taking only 1 star. Okay. And the next line I will go for, guys, because okay, maybe space is not adjust here, so that's why I'm taking next line. Okay, now, right? So comma after I will go to next line here. Next highest salary, after that what now? 1500. So 1500 is also having only one time. Next low salary, so 1250. The 1250 is having here 1250. The 1250 is having here how many stars, guys? Here 2 stars, because 2 rows are the 2 stars here. And the next comma, next highest salary, and before this highest 1300 na? 1300. 1300 is also having only 1 star. And after that 1250 is having 2 stars. And after 1250, what is the next salary? Okay, 1100. So 1100 is also having only 1 star. And now next salary 950. So 950 is also having only 1 star. And next one called 800. And it is also having only 1 star. So these are the arrangement of data on which column? Salary column. So the salary column data will arranging by your system in which format? Binary tree structure format. So whenever it was arranging like this, then what it was happening, you can see after that, as per this request, whatever user sending to server, then server Oracle server taking this request. Based on this request, server will checking that on the salary column any index object is created or not. First it will be checked. So when are you created indexes on salary column, then directly it will go to that index, and whatever the conditional value here it was be checking. So now this condition will be checking with the binary data. Okay, now so salary is equals to 3000. So your comparison starts with the root level. So root level here one comparison, so 3000. So 3000 is equals to 3000 condition true. Condition true means which side I have to go? Left. Okay, which side I have to go? Right side. Which side I have to go? Right side. 3000 is equals to 3000 right side. So right side I will come to you here. Parent level is there. So parent level 5000 is there. So now compare here. 5000 is equals to 3000. So that means 3000 is not equals to 5000 na, but 3000 is less than equals to 5000 na. Yes or no? Yes, 3000, okay, is less than to 5000. So less than means again it will go to where? Left side. And left side, this is called as what now? Child level. This is called as what now? Child level. Okay, now, right. Side. Now, three matching. So after matching this, here 2 row IDs are there. So here 2 row IDs is nothing but page number. Okay, now page number. So page number means here what happened? So 3000, okay, first row ID. So directly jump to the first row ID 3000, where it is here Scott. This record is retrieving from the table. And the next condition, one more row ID is there, and row ID is nothing but page number. So directly based on this row ID, directly going to your table, and second 3000 row data we got. So that means now tell me guys here, now this condition is checking in how many times this condition will be comparing here means there are 3 levels it will be compared, guys. How many levels? There are 3 levels it will be compared here. So first level comparison at root level, second level comparison at parent level, and third level comparison at the child level. And your data also where it will be saved here? In child level it will be saved. Okay, now so the same request when I want to retrieving data from a table. So here how much it was taken, guys? Here 3 levels or 3 comparisons it was taken. Okay, now 3 comparisons it was taken. But the same comparison when I go for table level, the same request it was comparing total 14 rows are comparing. Okay, now it was comparing total 14 rows comparing, but after index is created, it will compare only 3 levels compare. So first level, second level, third level. So in 3-level comparison, your data can be retrieval here. Okay, so this is what now. Okay, 3-level comparing. How many times here? 3 times. Okay, but there 14 times comparison is happening. So this is the advantage of what now indexes. Okay, how it will be, okay, retrieving your data fastly compared to table scan mechanism. Okay, now so this is what we called as here. So now these are what we call here. So arrangement of binary data or binary tree structure data arrangement. First root, parent, and these are all are called as a child level. Okay, now right. So this is simple. Okay, indexes. Okay, how it was working in the same pattern, guys. Here, next one is called as a composite index. So composite index is nothing but what means here observe. So when we created an index object based on multiple columns, okay, na? So based on multiple columns, then it is called as what now your, okay, composite index we called as. Okay, na? So when we created an index object based on multiple columns, then it is called as a composite index we called. Okay, and now come back and see the syntax of this. So now the same syntax, but here when you have to go for to apply your multiple columns, suppose I'm passing a column name 1, and now I can say column number 2, comma, and so on. So this is what we call as the syntax of composite index. So when we are using composite index, so now we can see, just come out here. So now on this EMP table, as of now, we created index only salary column, and we have only one index is there here. Okay, now only one index. So that index is created on which column? Salary. Okay, now this is what it was happened, guys, here. Right. So now I'm going to create one more index now. So here observe, create index name I2 on table name EMP of here my columns, department number, comma, job. Okay, so now we can observe in this syntax, guys, here. So now tell me, are you created index object on how many number of columns, guys, here? So 2 columns are you created, and let me check to execute this one. Okay, now fine, to execute this one. After executed, again you have to call this. Okay, so now we can see the index number 2 is created on department number as well as job column. We created index number 2 object. But whenever you created, guys, here one important point. So when you created composite index, it means we applied index object on multiple columns in a table. Then how these indexes are activated means here observe. Suppose if I'm creating my index on 2 different columns I created here. Okay, now then what it was happening, you can see when you go for test to index activated or not means, suppose when you call like this, select a star from EMP where department number 10, if I call, then immediately here which was activated means your index is active. So index is active here, and index scan is performed by here. Okay, your database server index scan is performed while data retrieval here. Okay, so and the same to same, but again if I want to call now, so select a star from EMP. So where job is equals to, if I send clerk. So now tell me, guys, here whenever I want to retrieving the data based on job column, Can you tell me, as per this request, your Oracle server will follow index scan or table scan? What is your guessing, guys? Come on, what you're guessing here? Okay, right. Yeah, yeah. So many people they're expecting what now? Index scan. They're expecting. Why they are expecting index scan means because in my index object creation, okay, we created indexes on this multiple columns. Okay, so that means it is also one of the indexed column. So that's why if I return this condition, then so many people expecting what now? Index scan will be performed, but that was wrong. So here it will be performing your database server, which scan is performed means a table scan is performed. Okay, so why sir table scan is performed, not index scan? And you people are asking, job is also one of the column in my index now. Then why it is performed here table scan? Okay, the reason is what now, guys? Here the least okay leading column. So indexes always perform based on leading column here. So in this two, which is your leading column, guys? Here DEPT number is called a leading column. Okay, so that's why when I'm using my leading column in my where class condition, then index scan is performed. But when you're using non-leading column, then table scan is performed. Okay, so non-leading columns whenever use, so table scan performed by default. But when I use a leading column, then only index scan will be performed. Okay, because here leading column is nothing but the first position of column in this. So how are you created index object on multiple columns? In multiple columns, which is your leading column, based on leading column only index can be work. Okay, but non-leading columns are indexes are not working. Okay, now this is what. But in the same case, I'm going to asking here. For example, if I'm going to sending my request to my database server, like DEPT number is 10 and job is equals to if I send clerk. Okay, and now tell me, if I'm using these both conditions now in my where class, then which scan is performed, index or table? What is your guessing, guys? Yes. So here it will be performed. Index scan is performed. Index scan is performed. Why, sir? Why, sir means in my where class condition, do you have a leading column? In where class condition, do you have a leading column? Yes or no? Yes. So that is the reason it was performed index scan. So leading column compulsory we should have in this where class. Okay. Okay, now so that is what we call. So in your where class condition, do you have a leading column along with a non-leading column? Leading column is the compulsory. The first priority is a index scan priority. Whenever we are not using this leading column and directly we are writing your non-leading column, then it is table scan. Okay, this is composite index working nature. And the next one is called as, guys, here what now? Unique index. So unique index, what it was telling us, guys, here. So this guy is observed. So when we created an index, okay, so based on unique constraint, okay, now based on unique constraint. So when you created your index with unique constraint, then it is called as a unique index we called. And unique index advantage is what now? Here observe. The searching time will be reduced as how it was reduced as searching time means to eliminating duplicate values. Okay, so to reduce, okay, searching time, okay, searching time because, okay, so because what is the because reason? Because okay, it restricted, because it restricted duplicate values. It restricted duplicate values. For example, let me see one small example. I will explain to you. Suppose here one serial number column, guys. So on the serial number column, I'm not creating any unique index, and this is serial number column, and I created unique index here. Okay, so now serial number this and this is the both the columns are there. Okay, then what happened if serial number here I want to enter 10 and here also I can enter 10, here I can enter okay 10, but I can't enter here 10 20 only. Here I can enter 10 and here I can enter 30. Here I can enter 20, here I can enter 40. Here I can enter 20. Okay, so here I can enter 50. Here I can enter 30. Okay, so next 30. Okay, next 40. Next 40. Next 40. Next 50. Next 50. So now here observe. So serial number and here also serial number, but this is a non-unique index and this is a unique index. So unique index, non-unique index difference is what now? So here duplicates are allowed here. So that means whenever you want to retrieve the data from this table, then entire the table, that means entire the column will be searching. So a column will be searching means total how many values are searching, including duplicates. Come on, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 times it was searching here. But when you applied unique index, how many searchings? How many searchings here? 5 searchings. But here serial number having same data and here also having same data 10, 20, 30, 40, 50, and here also 10, 20, 30, 40, 50. But here what is the problem? Duplicates are more. That's why searching time is more. Here duplicates are eliminated, restricted. That's why searching time is less. Okay, now. So this is the concept of what now? Unique index. Understand now? So, and how it was created, this unique index means, here observe. So create, here I want to use unique index and index name. Okay, on table name of, so I need to pass my column name. Okay, now, right. So let me see some example on this. So how to create it here, unique index here, observe. Suppose this is my table. So DEPT table is not there now. So just a moment. Okay, now come out and see here, select start from DEPT. And later come to, if I want to see on this DEPT table, do you have any index? If you want to see, you can see like this here and execute. Okay, this is EMP table and now my table is DEPT. So tell me guys here on DEPT table, do you have any indexes here? No, there is no indexes here. There is no indexes here. Okay, right. So now I'm going to create one index, and before that, I want to call my table. Select a star from DEPT, and on this, I'm creating. So unique and the unique constant name I3. Okay, so unique. So index I3 on DEPT of department name column I create. So now unique index is successfully created. Let you call your DEPT table. So unique index created and the index name is I3. So after created these indexes here, let me see to perform some operation. What it was happening, you can see into DEPT sending values 50 sales, and I'm passing here HYD. Okay, so whenever I inserted this data, can you see 50 department name sales, location Hyderabad. But tell me guys here, department name column, in department name column, already you have a sales now. Yes or no? Sales department already existing now. Yes, already existing here. So already existing, but still I'm inserting here. What happened? You can see it was showing error. The unique constraint is violated. And can you tell me guys here, which index is firing here? Can you see which index is firing here? Come on. I3. Okay, na? So I3. So now we observe the sales I'm inserting, but you're saying that I3, okay, your index, unique index is violated here. Okay, now so whenever we are not inserting duplicate values here, then what it was happen, my searching time will be less. Okay, when you have a duplicates, then searching time is more. Okay, and we have a without the duplicate, then searching time will be less. So that is the advantage of what now, unique index. Okay, and the next index is what now guys here, the next one is called as a functional based index. So what is functional based index here? Observe. So functional based index is nothing but guys here, when you created index, okay, based on a function, and it is called as a functional based index record. Okay, so that means these are very small definitions guys here. So when we created an index, a function, a functional based index record. So now the syntax is upload. Okay, right. So this is my syntax guys here, the functional based index here. Okay, so create index name on table name of here, what I'm using, function name I'm using. Okay, so on particular column. Now for example, let me see guys here. So now I'm going to create a, okay, so when come to my table, this is my table and one index is created, index I number 4, okay, on EMP table of then I'm using one function here. My function is what now, upper function. Okay, now so upper of e name. Okay, here my function is what now, upper function I'm using now. So how I was created here, so create index name on EMP of upper of e name column, upper of a e name column. So whenever you want to use upper of e name column and to execute this one, what it was happening, you can see your index is successfully created. After created this index, let you call your indexes. Okay. So now you can see, so my index is created, but here's one function, okay, identity number system is generated. This is a which function I'm using here, the function identity we called here. Okay, now, and my index name is what? No, I4. Okay, right. After created this function, how it was going to be using means, for example, if I say select a star from, okay, emp where compulsory this function I have to use upper of ename is equals to, if I'm sending Smith, I'm sending no. Okay, so now tell me. So whenever I'm passing here, so where condition and which function I'm using here, the compulsory the function column must and should be used under where class. So when I'm using like this is equals to Smith, what it was happen, I am asking upper of ename, but I'm giving what now? Smith, small case character. Then when I was given like this, what it was happen, there is a no row returns because my condition is not satisfied. Okay, and still you have a Smith data in the table. Still you have a Smith data in the table, but what it was happening guys here, so it is condition is false, it's not true because I'm asking upper name, I'm asking but writing lower name, so condition is not satisfied. When condition is not satisfied, now your indexes are not working here. Okay, that's why there is no return value. Okay, but in the same case guys here, in place of that the capital I'm sending now, so now condition is true because I'm asking upper of e name. Okay, and I'm also giving my name is also in uppercase character, so that means uppercase. Okay, I'm asking, so I'm giving uppercase, so both are condition true. Condition true means immediately your index is activated and fetching your data from your table. Okay, now let me see to execute now. So Smith data successfully be fetching. Okay, now so this is okay the functional based indexes how to create it. Okay, and these are all are comes under which category of indexes means these are all are comes under so B tree category indexes now. So single column, multiple column, unique constant, functional base. Okay, now these are B tree indexes we got. And the next one is called as what now? Bitmap indexes. Okay, but guys here, bitmap indexes, I will explain to you on Monday session. So tomorrow no class here, and Monday onwards again your offline classes also started. Okay, now so I will available in Hyderabad from Monday onwards. So again, who are offline students are there. So please come to offline classes from Monday onwards. Okay, now offline students, are you clear now? Okay. So again, users come to offline students, offline classes, online students, online classes. Okay. So actually tomorrow, I started to go. That means I'm coming to Hyderabad. Okay. So then Monday again, your as usual classes are started. Okay, and actually I planned Saturday I want to take doubt session, but that will be postponed into next week. Okay, that will be postponed to next week. Next week I will take a doubt sessions for complete complete you guys. Okay, right. So I stop it here guys here, so because of reason I have some little bit work. Okay, now and tomorrow no class, and come on Monday, and Monday onwards your offline classes also started, so offline students come to offline classes as usual. Okay, and online students come to online classes as usual. Okay, now clear now all of you? Right guys, so on Monday session we will discuss about bitmap indexes. Okay, right. Thank you guys, thank you so much.
Recording stopped.